All right, the rest of section 1.4 is about even and odd functions and their symmetry. Now, we have talked about even degreed and odd degreed functions, but that's not the same as saying a function is even or odd. Even or odd has to do with symmetry. Now, the test for even and odd is to find f of negative x. That is how we test for symmetry. So if it says show work to justify your answer, or test the function for even or odd, or if it's a free response where you have to have work shown, that is what I expect to see, is that you tested f of negative x, okay? So here's the rule. A function is an even function if when you do f of negative x, it comes out exactly the same. F of negative x is equal to the original f of x you started with, okay? So that means your equation doesn't change at all. F is an odd function if f of negative x gives you the opposite of f of x. That means that every term of an odd function changes sign. If 3 terms change a sign and 1 stays the same, it's neither. It has to be all or nothing, okay? So here's how we can kind of test that. So here are some examples here. So for each one of these, the test is going to be to find f of negative x. So for this first one, and this is just practice with function notation like we've done, f of negative x would be negative x squared plus 6. Now, I know that this is stuff you can do in your head, but if we're trying to show why it is even, odd, or neither, you got to have work shown to show how you do it. So you need to at least write out what f of negative x is. It's going to be negative squared is going to be positive x squared. Positive 6 isn't going to change at all. So do you see how everything came out exactly the same? That means this function is even, okay? If I look at number 6, g of x, g of negative x is the test. And this is the part, you can do it in your head if you want. A negative number to an odd power would make this negative 7x cubed. And then minus x is going to be plus x. That's what we get. Now, if you're not quite sure where that is coming from, then write it out. G of negative x is going to be 7 times negative x cubed minus negative x. The parentheses are really important, but that's how we get to negative 7x cubed plus x. If we look at what happened, I had positive 7, now I have negative 7. I had negative x, now I have positive x. So every single sign switched, that makes this function odd. Okay. Number 7, same test every time, h of negative x. So for similar reasons, if it's an odd exponent, that doesn't mean it's an odd function, but if it's an odd exponent, we'll get a negative when we plug in negative x. And then a constant is called a constant because it stays the same. So here's what happened. The x to the 5th changed signs, but the 1 did not. That makes this neither. It's neither odd nor even because it either all stays the same or every term switches. So that's where number 8 gets a little bit tricky, because p of negative x raised to the 3rd power would be negative x cubed times the square root of negative x squared would be positive x squared plus 1. So the question is this odd or even or neither? And you may want to say neither because the x cubed switched, but the x squared didn't. But all of this goes back to what we talked about at the very beginning. All of this is one term because it's multiplied. So this one term started as positive, and now this one term is negative. So that makes this function odd. It's really tricky. We need the square root to stay exactly the same because that's the type of term that we're counting. So we just need the sign in front is the only thing that changes. Like negative 2xy and positive 2xy. The x and the y didn't change, but the term changed from positive to negative. It's the same kind of idea, just an uglier term. So be careful on ones like those. What does that mean when we find even, odd, or neither? What it tells us is it tells us the type of symmetry that the graph will have. Okay, so even functions have y-axis symmetry. That means they're symmetric with the respect to the y-axis. So that line of symmetry right down the center at x equals 0 is where we can divide the function in half. Every point that's on this side is also on this side similarly. And look at what happens. I have positive 2 and I get 4. And when I plug in negative 2, I also get 4. If I choose an x, I'm going to get an f of x. And if I choose a negative x, I'm also going to get an f of x because it's going to be the same on either side. So that's why the test works the way it does. Okay. Odd functions, this one is a little bit weirder. Odd functions have what is called origin symmetry. And the easiest way to test for origin symmetry is that for every point xy on the graph, there is an opposite point negative x, negative y on the graph, okay? So here's kind of a general xy over here, negative x, negative y over here. Positive 2, positive 8, negative 2, negative 8 has to be on the graph. That's how we check for odd. If it is not either of those, then it does not have odd symmetry or even symmetry. So odd and even only means those specific kinds of symmetry. I remember all the O's go together. Odd, opposite, all the signs switch. Origin means it has origin symmetry. Origin symmetry means that the points are pairs of opposites. Odd means that all the signs switch to opposite when you test the equation. So let's look at the graph and see if we can identify the symmetry on these last 3 examples. So for A, first we look, does it have y-axis symmetry? Definitely not. I can't fold it in half on the y-axis and have it match up. Then the next question is, does it have origin symmetry? So let's pick a point. This looks like the point maybe 1, 4.5. If it has origin symmetry, then negative 1, negative 4.5 should also be on the graph, which it is not. So this one is neither. It's neither odd nor even. It might have symmetry, but it is not specifically odd or even, okay? If we look at B, this one we can see is symmetric down the y-axis. If I fold it in half, the 2 sides are exactly the same. That makes this graph even. Now, if I look at C, it does not have y-axis symmetry, but if I pick a point, like this one here, this is positive 5, negative 4. That means that negative 5, positive 4 has to be on my graph, and it is. Positive 3, 0, negative 3, 0 is on my graph. So this one is odd because it has origin symmetry. So that's what we're looking for. One thing to point out, if I shift the graph, it may not have the same symmetry anymore. For example, if I took this graph on B and just moved it over like this, that yellow graph is no longer even. It has symmetry. It has a line of symmetry right here, but that line must be the y-axis in order for it to be even, okay? So you got to pay attention to that very specifically. And so that is what you need to know about even and odd and the different types of symmetry that we like to look for.